What's your resolution? I pun tak tahulah kan. Already too old to celebrate. Okay. Let me see now. Wait, ramai lagi. Admit all. Okay, so don't forget to key in your attendance. Don't forget to key in your attendance. Yeah, attendance in Putra Blast. Yeah. Hopefully Dr. Saufi create attendance up until week 14. And then there's another reminder. So now I think now is week 12. So usually beginning week 12, usually the lecturers will politely ask you, reminding you to do teaching assessment. So while we're waiting for the others, you may do your teaching assessment for this particular subject. While we're waiting for others, maybe I will start in 3 minutes time. 9:55. Don't worry, chi-square lecture is usually very short. 1 hour can finish. So while we're waiting for others, you may do your teaching assessment for this particular subject. Okay, admit all. Yeah. So I'm currently still marking your test 2 papers. Maybe today I can finish up to 50%. Halfway to go. Yeah. Okay. Not too bad. Most of you, not too bad for your test 2. Alright. Okay. So sekarang, okay. Tunggu dulu. Okay. Okay. Okay, alright. 9:55 I will start. Okay. So refer to the previous lecture notes, because lecture notes on non-parametric tests, I've stopped at Man Whitney, multiple pairwise test. So today we just continue with a chi-square test of independence. The same lecture note. The second half of the non-parametric lecture note. Just open the lecture note. It's the same thing. All right. Okay. Yeah. So while we're waiting for the others, please do the teaching assessment while we're waiting. Banyak lagi yang tengah masuk ni. 77. Ada 30 orang lagi masih celebrate New Year. Tak masuk-masuk lagi. Okay. Alright. Okay. Okay. So I should record first. Record.
Recording in progress.
Okay. So boleh dengar ya? Okay. Alright. Clear. Loud and clear. I need to adjust my microphone. Okay, Aliana Maisara admitted. Okay. Okay. So I like to share so I would like to share from iPad. Okay. 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 All right. Okay. Okay. So, Assalamualaikum and good morning. Okay. To those who just joined us, so we are now starting on today's lecture. Today's lecture. Supposedly yesterday, but yesterday is still New Year's holiday. Okay. So, ramai tengah masuk Okay, so for today, just continue on the non-parametric lecture slide. Okay, go to chi-square test of independence. Okay, and the second part of the non-parametric test slide. Okay, slide number 27, something like that. Okay. So for today, okay, okay for today, okay. Okay, this is chi-square test of independence is maybe okay, quite special. It's standalone. Let's see if you have what a t-test, as parametrics, then you have maybe Man-Whitney as their non-parametric counterparts. And this one is standalone. This one, chi-square test of independence. When you collect your data, okay, so this is like the idea behind it. Is the variation in your data just due to chance? Just due to chance? Or is it due to one of the variable that you are actually testing? Okay. So if you want to recall back, if you recall back a lecture, I think previous week, on non-parametric test, if you remember, there's a scenario. Let's say you want to have a party. You want to have a party maybe after the conclusion of test or final exam, and one of your friend is tasked to buy soft drink, many cans of soft drinks, okay, consisting of many flavor, many brands. Okay, now, okay, so he collects money from you guys, and then off went to a grocery store, and then buy a groups of multiple brands of soft drink. Now, when you are at the party, and when they, when when your friend put the soft drink on the table, and he observed the groups. Okay, is there a possibility that you will take the soft drink randomly, any flavor will do, or is there any pattern to it? Maybe this group of people, this cohort prefers more on Pepsi, prefers more on Coca-Cola. Now, is there any pattern to it? So, is the collection is, let's say, if somebody are going to do some observation on the pattern of your soft drink choice, would that be by chance? Means any of you will take anything available on the table, regardless of the brand, regardless of the taste, or actually you have an inherent preference toward a certain brand or a certain flavor. Okay, now, as you might know, this is nominal. A nominal type of data, meaning there's no continuous scale. You don't measure. You don't measure someone's preference, and then it's not in any particular order. So let's say Pepsi is not higher rank than maybe Coca-Cola. Kickapoo is not in higher status than any other soft drink brand X. Okay. So it's nominal data. You want to find a relationship between nominal variable. Okay, so this test was developed in the early 1900s by Carl Pearson. So usually this test is also known as Pearson chi-square test. Pearson chi-square test. Okay, for those who are just joining, so the how to pronounce it is not chi, CHY is not chi. It's not something out of a kung fu movie, no. So it's pronounced chi. CHI is chi. So it's also known as Pearson's chi-square test or chi-square test of association. How is there any association between these two nominal variable? Okay, that's what we want to try to find out. Test of association. Okay. So this test is to help us to understand the relationship between two categoric variable. Okay, which can be nominal or ordinal. Example, smoking status versus education level. Does smoking status affect education level or vice versa? Does education level has some influence over smoking status? So this one is slightly different than the previous laboratory on two-way ANOVA. Two-way ANOVA is just to know whether your lung function, is it any way in any way influenced by your education status or your your education level or smoking status. In this current form, is education level somehow affect the smoking status of a particular batch of person? Okay. So smoking status is categoric. Education level is ordinal. Categoric ordinal. Smoking status categoric nominal. Okay. Okay. So chi-square. So how to write chi-square is like an italicized, a very fancy italicized X with a square. So that's how you write chi-square. Involves frequencies, frequencies of event. So you count. It's a counting. So it's not measurable, but it's countable. Not dependent on the numerical value like population mean or standard deviation. Okay, so this test is always produced, is always done on what we call contingency table. Okay, how you perform this test is you have some sort of contingency table. We call it, or what we call cross tabulation. So what it does is display cross grouping of categorical variable. Okay, very easy to understand. If I show you later how the table look like. Okay. So what chi-square does is to compare what we actually observe, with what we expect oftentimes using population data or theoretical data. Okay. What you actually observe from this group of people and then compare with our expectation. Okay, expectation is based on previous population data or by theory. Okay, so so how to conduct chi-square is you have to use chi-square distribution table. Look something like this. Look something like the look something like this graph below. So the chi-square distribution graph has a function of depending on the how much is the degree of freedom, and the critical value. Okay, so you have to specify in order to run chi-square test. Usually you have to know the population, sorry, the row and column sample size. Yeah, which is you're going to find out in the contingency table, and then define the degree of freedom. Okay, this is also we get from the contingency table, and then critical value, in order to accept or reject our null hypothesis. Okay, so what is our null hypothesis? Okay, null hypothesis is the statement of no statistical difference between observed and expected frequency. Okay, that is the two variables are independent. So that's why sometimes you also call this chi-square test of independence. These two variable is independent or are independent. Okay, so that's the other word of test of association. Chi-square test of independence. Both refer to the same thing. So the formula is quite simple, very simple. You only have to know this one particular formula, which is chi-square equals to the frequency of observation, OI, observation of the ith frequency, minus expectation, expected value, and then you square the numerator part, and then you divide by expected frequency, and then you sum up everything. So it's a very simple formula to remember. Now, for the first example, to give you maybe some idea on how chi-square works. Okay, this. So let's say I have two dice in my hand. Okay, one is fair. Fair mean a normal dice. It's how many? 8-sided. 1, 2, 3, 4, 5, 6-sided. Okay, 6-side dice. It's a fair dice. 6-side is a fair dice. Maybe factory manufactured. So, and another one, another particular dice is what we call tempered. You rig the dice. Okay, which is, for example, here, number 1, number 5, number 6 is loaded. Okay, means you already rigged the dice. Okay, so when you throw the dice is actually not of equal weight distribution. So whenever you throw the dice, there are chances that either number 1, number 5, number 6 will come up on top. Okay, due to your altering the weight. So this is a rigged dice. So this is like if you want to, let's say, go to Genting Highland, you want to smuggle this dice, you want to win some betting. Maybe you play some, card game and then require some throwing of the dice. You want to use this dice instead of the house issued dice. Okay, this is a very subtle way of cheating. Okay, bukan bawa toyo, bukan bawa jin. This is a subtle way of teaching. Cheating. Mathematical style. All right. So one is fair. One is fair means you don't put some weight inside the dice. The other one is you rig the dice. So you have a likelihood of getting 1, 5, 6 whenever you throw. Now, I lend you one of the dice and ask you to determine if it is a fair or loaded dice. Okay. So I need your answer to be 95% in conclusion. All right, 95% confidence. So what you're going to do for over the next day, 6 days, I want you to roll the dice 100 times. 100 times. So six days for consecutively 6 days means 600 roll. And record how many times each number will came up. Okay, very simple task. So you go back home and then you start rolling the dice 100 per day. Now let's assume the dice 600 times throwing. Now let's assume the dice is fair. What is our expectancy? What is our expectation? So perhaps on the most idealistic condition, number 1, number 2, 3, 4, 5, 6, you might expect that the frequency of that number will turn up to be equally distributed, hundreds. You throw 600, most number will came up 100 every time. Okay, number 1 for 6 days will turn up 100. Number 2 for the course of 6 days also you sum up 100 times will came up number 2. So this is the most idealistic situation. So this is what we expect. So every number may came up 100, 100, 100, and you sum up, you get 600 throw, 600 roll of dice. Okay, this is your expectation. Okay, so your null hypothesis will be the dice is fair. Okay, of course. If you don't rig, if you don't do anything, the status quo will say the dice is fair. But your alternative hypothesis is the complete opposite. The dice is not fair. Or the English way of saying this is is the variation in our observed data simply due to chance? Is it due to chance or something else? Is the variation beyond what random chance should allow? Okay, when you throw, does it pique your curiosity that there is something wrong with the dice? Okay, this is a subtle way of cheating. Not like in scenario like in Alibaba Bujang Lapuk. In Alibaba Bujang Lapuk, there's a character, the sergeant of the 40 thieves, go to the market, and then play a betting game against the crowd. So his way of cheating the crowd is very simple. He has a dice with number 2. For each 6 side, they have number 2. So the crowd can bet any numbers except number 2. The number 2 belongs to the house. So when he throws, when he throw the dice, so if the people choose other numbers beside number 2, they will lose. They will lose the bet against the house. So that's a blatant way of cheating. This one is a subtle way, more professional. Okay, when you throwing the dice 600 times, does it intrigue you to say that there is something wrong with the dice? Okay. So how far can our data vary before we have to reject our null hypothesis and conclude that the dice is not fair? Okay, how far? How far you can allow the frequency of this occurrence happen before you can conclude that okay, there's something wrong with the dice. Okay, so at confidence level of 95%, of course your p value should be less or equal to 0.05. Okay, okay, that's clear cut. You already know how to calculate p value. And the degree of freedom, because you have 6 sides, the dice have 6 sides, so degree of freedom is 6 minus 1 is 5. Okay. Now how to calculate? Yeah. So your test statistic, you will find out from the contingency table. Okay. Now, first you can do is, what you can do is, you have p-value of 0.05. So what would be the chi-square critical at p-value of 0.05? Okay, the simplest way is because you are no longer have to refer to table. Maybe student 20 years ago have a statistical table, but nowadays you can punch in the Excel. So this is the syntax. This is the command in the formula bar. You just type as such. You just type. Okay. Chi inverse, okay, this CHI inverse stands for chi inverse, open bracket probability, and then degree of freedom. Okay, that's how I say that. When you need to calculate chi-square, you need to know the degree of freedom. You need to know the probability. Okay, so just simply punch in any other cell, any particular cell, right as such, and at p-value of 0.05, the critical chi-square given here is 11.07. Okay, okay. At degree of freedom equals to 5. If you have different degree of freedom, it will calculate otherwise, different numbers. Okay, now that's settled for critical value. Now, what will be the chi-square test value? The test statistic value. Okay. So you observe. Okay, this is your actual experimental run. Okay. So at the 600 throw, so number 1 came up at 111. Okay. Okay. Number 2, 90. Okay. Number 3, 81, 102, 124, 92. Okay. Because you throw at 100 frequency per day for 6 days. For 6 days straight. So you total up 600. Okay. This one is expectation. Very idealized situation. This one is the actual. What you did. Now, what you need to do is you just minus. You just what you have to do is the observed number. You have to minus the expected numbers, the expected frequency. So Observe minus expectation. So for number 1, you have 11. Number 2, 10. Minus 19. Number 3, number 4, 2, 34, minus 8. Okay, that's the deviation. We call this deviation. Okay, and then you square, and then you proceed to square the deviation because you want to have a positive number. Modulus, you don't want to have negative number because here at the number 3 throw you have minus 19, number 6 you have minus 8, so you need to get a positive number, so you square everything and then you divide by the expected frequency. Okay, so after you have done this and then you sum up, because the formula require you to sum everything. So your chi-square, your test chi-square is 12.26. Okay. And straight away compare with your critical value, chi-critical. So we can say that if our chi-square is more or equal to 11.07, then we must reject the null hypothesis and claim that the dice is not fair. So 12.26 is more than 11.07 straight away. So in this case, we just comparing the chi-square. We just calculate the chi-square. So for p-value, that correspond to 12.26, we have other means. Not by using this. This is simply by comparing chi-square critical and chi-square statistics. If you want to compare p-value, there are other means of doing it. Okay, now that is one variable. Very simple. How about two variable? Okay, two categoric variable. Okay. If you understand the first one, single variable, and now two categoric variable, you already can understand if you have more than two variable. For a cross tabulation table that has more than two variable, you can actually do it. Okay, so example 2, pass or fail exam. Okay, so data of a class of 54 students who appeared for exam, and then whether or not they actually attended class or likely to skip biostatistic class, just like today. Maybe only 64 of you. 64? Is it 64? The rest is still in dreamland. Okay, contingency table or cross tabulation table. Biomodeling class, mana ada biomodeling class sekarang kan? Mana ada kan? Biomodeling class Thursday. Okay. Oh, I know. Pierre like to skip biomodeling class. Oh, okay. Thank you. All right. Now, so you have two categoric variable here. Okay. One is either you pass or you fail your exam. The first one. Okay. Passing or failing your result. And then the second variable is your attendance. Do you actually attend the class or skip the class? Everybody can skip the class nowadays. Just switch off your webcam. That's how you skipping class today. Okay, now, so this is the actual data. So what happened is there are 54%, 54 total. Those who pass and attend, ni goody two shoe lah, 25. 25 student actually attending biostatistic class and actually passing. Okay, this one is like very common sense. Attended but fail, 6%. Dia dengar apa aku pun tak tahulah time aku lecture kan. I don't know lah what they are listening to. Still attend but still failing. Rajin tapi okay, now pass but skip the class. Oh, ini insan terpilih. 8 orang. And then skip and failing. Oh, yes. You get your comeuppance. 15 of you, right? So you have a total of column and rows. So the important here is to know the column and the row total. Okay, that's how you going to calculate your test statistic. All right. Now, okay. So what is your null hypothesis? No difference in the result whatsoever. Whether you attend or not. This by statistic class. No different in the result. Okay. Alternative hypothesis is students who attend the class have different pass percentage. We don't say student who attend will pass. No, we can say that student who attend have different pass percentages. Okay. That's the diplomatic way of saying your alternative hypothesis. So how to calculate the degree of freedom is the numbers of row, which is 2 minus 1. Yeah. And the number of column, which is also 2 minus 1. So all in all, you get on 1. Degree of freedom is 1. Very simple. For 4 times 4 table, your degree of freedom is 1. Okay, now how to calculate? Calculate your expected value. Okay, this is the top one is your observed. This is your previous table. Now, expected. So that's why I made it in different color. So I made it in different color for you to understand how we calculate expected value. Okay, so expected value maybe I put it as highlighter maybe. Okay. So this is how maybe in a word to express it. So for passing, expected people to pass this exam is the total that pass, multiply the total that attended, divide total student in the class. Okay, that is expected numbers to pass. Expected to fail is how many people fail. Multiply by how many actual people attended, divide by total number of students. Okay. Skipping, okay, pass but skip the class is total people passing multiply by total people that skip, divide by total student in the class. And then failing is how many people actually fail multiply by how many people actually skip, divide by total student. Okay, so that's how you calculate expected frequency. Okay, so you will got this particular figure. So passing maybe if you round up to you round the numbers. Okay, passing maybe 19. Expected to pass and attended should be 19. Attended but failed 12. Wow. Must be a very tough subject. Attend but still fail, higher number. 12 people should fail this. Even if you attend the class. So meaning this by statistic is a very tough subject. Pass but skip. 14. Also very high. Fail and skip 8. Okay, or 9. If you round up to the nearest figure, 9 people should fail. Skip and fail is 9 people. All right. So how you calculate your chi-square? Yeah, so how you calculate your chi-square is, okay, so you put side by side your observed table and your expected table and you proceed to do, you replace in the equation, in the chi-square equation, and then you sum up, you will get 11.7. So I round up to 1 decimal places, it should be 11.68 something. Okay, that's your chi test, test statistic. Okay, so what you need to do is calculate the critical value. Of 4 times 4 contingency table. You came up with 1 degree of freedom. 1 degree of freedom. And then from Excel, you punch in the formula. You will get 3.84 critical value, critical chi-square. So conclusion, since the calculated chi-square, the one that you calculated in the table is 11.7 for degree of freedom of 1, which is more than critical value at 3.84. Therefore, we reject the null hypothesis, meaning there is, if you attend biostatistics class, most probably your pass percentage will be different than skipping. So, there is some effect of attending this class towards your passing or failing your test. Okay, something like that. Okay, so chi-square test, chi-square test. Okay, so the chi-square should be 0 when the observed frequency are exactly equal to the expected frequency. Of course, when you put in the value in the formula, observed minus expected equal will yield 0. 0 divided by expected frequency is 0. Large chi-square means that the observed frequency are far from what we would expect if our null hypothesis were true. Okay, of course. The larger the chi-square, the smaller the p-value. Okay, which is less likely difference due to chance. There must be something happening. There must be some pattern. Like the die, like the dice problem. If the chi-square is very large, then and the act of you throwing the dice when it turn up the numbers, most likely the numbers that turn up is actually due to something else, not by chance. Maybe by some contraction that I put inside the dice, some weight distribution. Compare the chi-square with critical value from the chi-square distribution with row -1 and column -1 degree of freedom. You will obtain p-value. Okay. Assumption, all expected cell frequency not less than 1. Okay. So your column, your cell in the contingency table should have a value more than, not less than 1. At least has 1, not 0. And not more than 20% of the expected cell frequency is less than 5. If you calculate 20% of your cell in the table, in the cross tabulation, must not less than 5. This is the assumption. Okay. So this is exercise. Actually, it's not free time lah. Sekarang pun boleh buat kan. Okay. Now, in this experiment, you publish flyers promoting new nasi kandar restaurant. Okay, maybe you take some, free time, part time, maybe in ICT Mall, promoting apa nasi kandar restaurant kat sana. Banana Bro, something lah. Banana Bro baru buka. Okay, so the owner give you flyers. Okay, ask you to distribute to the passers-by. Okay, 3 different colors. See how many people take them. Okay, or not. Is there a random act of just taking any pamphlet, any color will do, or actually people prefer a particular color. Okay, so that's the situation. Okay, so observation, white, blue, neon pink. Okay, so that's the one variable is your brochure color. Your brochure color. Okay, okay. And then the action of taking and not taking, taking and not taking the brochure. Okay, is there any preference toward a certain color? Okay, so this particular cross tabulation table is R -1 multiplied by column -1. So row is 2, 1, 2. So equal to 2. Column should be 3 minus 1. Sorry. Row is 2. Row is 2. So that came up with 1. And then the column is 3. So 3 minus 1, 2. So your degree of freedom is 2. Okay. All right. So this, if you don't want to have the hassle of doing it by using Excel, because you need to calculate manually your expected frequency. So at the end of this at the end of this slide, I also give you how to calculate chi-square online. So just go to this website. Okay, and this one is this slide is newly added to the slide. It's not in your slide. I will update this, upload this in the Putra Blast later. Okay, so just stop sharing. Okay, okay. So this is a very simple, calculator. You can access online. Okay, so let's see. Let's see. Okay, this is the calculator. Okay, so just wait while I'm. Okay, okay. Let's have a demonstration a bit. Demonstration a bit. Okay, demonstration a bit. Okay, so I hope you can see the screen. My screen. Okay, my screen. All right. Okay, so let's repeat the pass and failing example. Pass and failing example of biostatistics class. Okay. So, so you have about so this calculator can cater for 10 multiplied by 10. So 10 column and then 10 rows. Okay, and that's the maximum. But it's more than enough for you. If you want to do any particular test, okay, just go to for any particular test with regards to chi-square, you can go to this website, quantsci.org slash chi-square.htm. Okay. Okay, so this particular we repeat our previous example on the pass failing, skip or not skipping the biostats class. Okay, so pass and attended 25. Okay, so if I were to somebody should switch off the microphone. Ada crackle sound. Okay, whose microphone is that? Let me see whose microphone is that. Okay, dah hilang dah. Okay, alright, okay. So those who pass and attend the class is 35. Okay, those who still fail but attend the class is 6. Yeah, those who pass but skip the class, very special breed of people, 8. Fail and skipping the class. Okay, so calculate. Okay, so you will get your chi-square is at 11.686. So that previously I round up to 11.7. Degree of freedom is 1. So this is the p-value, 0.00629, which is very small compared to 0.05. That's why you can reject the null hypothesis. Okay, Yates chi-square and Yates p-value I don't touch in this particular topic. Maybe you can have further reading on what is Yates chi-square and p-value. Okay. How about the banana bro situation? Okay, banana bro situation. Okay, so if you refer to your slide, okay, this is our last exercise for today. Okay, if a person take the white brochure, there are 32. So there are 150 in total. And then those who take blue, 38. Okay, those who take neon pink brochure, 20. Those who don't take blue is 8. Also 8 here. Those who don't prefer white, don't take white is about 8. Those who don't take blue, 22. Yeah, maybe I should enlarge this. And those who did not take neon pink brochures, 30. All right. So, kenapa ni? Okay, calculate. Alright, So you have 90. You can see the end of the row here is 90 total. And then those who take the brochure total 90. Those who don't take brochure 60. So you go down, total 150. Also correspond to the numbers, the total of row, which is those who take white. So those who consider for white 40. Consider for blue 60. Those who consider for neon pink 50. So total 150. So your chi-square is 15.278 degree of freedom 2. Okay, for the 3 multiplied by 2 contingency table, you get degree of freedom 2. Okay, just straight away see p value. P value, you want to go against 0.05. Okay, in this case, p value is 0.000481. Meaning what? There is a significant choice of people choosing a particular. There is, the color does affect. The color of the brochure does affect the choice of people taking or not taking the brochure. Okay, you can make a conclusion like that. Okay, status. Okay, all right. So that's end for our lecture for today. Of course. Habis pukul berapa? 10.37. Yes. So chi-square is very short usually. I can finish in less than 1 hour. Okay. So that's for today. Thank you. Stop recording.
Recording stopped.
Okay. So we have another maybe 2 more lectures. One on correlation and one for regression and finish for this semester. Okay. But we still have a lab to attend to. All right. Thank you for today. Okay. Happy New Year again, for those who just came in. Happy New Year.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Happy New Year.
Thank you, Doctor.